models which we'll be covering today will be basically comparing it with the traditional network. So firstly, we'll be looking at what a traditional network looks like what are the challenges in a traditional network. Later on, we'll be looking at what software defined access is, exactly how it looks like, the roles and terminologies, or what exactly is revamped. Then we will have a look at the benefits of software defined access over the traditional network. And later on, it will be kind of some fundamentals of the DNA center. What is intent based networking? Intent based networking, basically the platform on which SDA is built, and the architecture, and just few personal experiences working with software defined access. I'm sure and everyone might be from a networking or a security background and have at least a good idea of how a traditional network works. So I have assumed that everyone has at least a basic understanding of what a network looks like. So we'll not be going deep into the traditional network concepts. We'll be focusing more on the SDA part. So before starting, I would like to introduce myself. My name is Pranav Nangaonkar. I am a technical trainer for SD-Access, ICE and Duo Security MFA at Networkers Home. I am currently based in Toronto, Canada, and I am a Cisco certified specialist for dealing with specific product of ICE as well as CCNA security certified. I am currently doing my postgraduate in cybersecurity here in Canada, and I have 5.5 to 6 years of industry experience working on network and security technologies, including all these in which I have my expertise. So, yes, starting with the challenges in traditional network. So I want this session to be very interactive because when it will be more interactive, you'll enjoy more of this stuff because trust me, this technology is very interesting. It is very easy to understand. And when you ask more questions, I'll be more happy to answer them because I don't know how many of them are aware of the SDN world, which is currently involved. The network part is involved, but yes, SDA is one of the key factors in the SDN today. So I want to make it more interactive. If you have any questions, just put it on chat, or you can just unmute and ask me then there itself. So the challenges in traditional networks today. So I'll start it with an example. Consider we are a network and you want to add a specific user. Now we have organization here. Consider it as networkers home itself. Let's get it more personal by considering the example of our own organization. Now this is networkers home. We have infrastructure, we have couple of users, and everything is connected like in a traditional fashion. Everything is connected to the three-tier architecture. We have a router, then we have a firewall, then we have a access switch wherein all these users will be connected. Ignore my drawing, I'm very bad at drawing, but I'll make sure you understand it. Now, when I have to add any new user, for example, I want to deploy this workstation and it is like in a new condition. So what all are the aspects? Sorry, someone is saying, can everyone be on mute while I'm talking so that the others don't have the disturbances? Thank you very much. So when we want to add a specific workstation, what are the aspects which we look at in the current traditional network? Everyone might be aware. Let's have a look at that. So it is basically the first and foremost thing comes is the VLAN assignment. We assign a specific VLAN to the port, consider VLAN 20. Then we take a look at the ACLs, whether this has to be given a specific access or denied a specific access, considering the role of the employee. Then we have to join this machine to the domain. That is all related to the application part, so we'll not look into it. We'll deal with the network part specifically. Then we have to integrate this with the Active Directory and check if the reachability is done. Then assign it to a specific OU, then assign specific access control if we have any specific identity system like Cisco ICE. So all these aspects come into picture even if we want to, when we want to add a specific user or a computer system into the network. So this is kind of what you can say a bit challenging. I'm sure everyone might be aware of this. You can see the hefty list of the access list. The access list number is just one. It's a extended access list 102. You can see so many permits and denies with so many IP addresses. Everything IP addresses. Different IP address, subnet mask, source and destination, port number, deny, denial, permit, permit. You see how many of them? And it is very difficult, trust me, it is very difficult to keep a track of all this when the network gets on expanding. It is very difficult. I've worked with organizations who have up to 10,000 ACLs on a single L3 switch or a router. 10,000 ACLs, can you imagine the number of lines it would extend to? It's very difficult to keep a track. And again, during troubleshooting, you have to filter among the specific IP address for the specific access list. And then you have to kind of shortlist a specific line, and then you kind of troubleshoot it. You kind of apply a no access list, or you can nullify it and then check whether the access is running. Then later on you have to keep a note that somewhere I have nullified this and I have to get this working for my security. That's a problem, right? That's really a problem. So if you see, the enterprise networks are very complex today. Those are very complex. Not only the data center, but the campus networks. Even if it is for 2 or 3 campuses in the network, including the data center, it is very difficult. So as we discussed, some of the problems, just an overview. Setting up multiple VLANs. There are hundreds of VLANs configured. Now you see in this headquarters, you can call it a data center basically. There are multiple VLANs, but we don't have to deal with the headquarters because headquarters is a data center and we are not dealing with data center. Now this is branch A. Again, they have a different VLAN. If you see, this VLAN A is different. This VLAN 1, 2, 3 is different. So nothing is uniform between the headquarters and the branch. If you see this branch B, a different VLAN. The remote networks, the people connecting over VPNs and all other remote technologies, they have a specific different VLAN. So setting up multiple VLANs is a challenge. Dealing with disparate networks, like a kind of the architecture is completely different for every single branch, the headquarters, be it a remote setup, anything it is. It will be a three tier architecture over here. And sometimes you see if the branch is smaller in size, can everyone be on mute, please?
Vamsi, your mic is open. Yeah.
Thank you. Dealing with disparate networks, we are discussing on this. It is more of a different architecture. Now you must have seen that. Specifically, this is in my working experience. There are most of the banks who literally isolate some of the branches or keep it like a very simple infrastructure. Like they just have a router, they just have a switch, and they directly connect their endpoints. So it's difficult. No security, nothing. Just go via this way and you have access to the headquarters. I even have found out many loopholes in one of my vulnerability assessment reports that it is very easy to get from this weak branches to the headquarters, which is a security concern, right? Next challenge is defining policies for LAN, wireless LAN, and WAN. Now, if you see, organization has basically three types of connections. One is wired, next is wireless, which we will call it to keep it simple, WLAN, and one is WAN, but again, instead of considering it as WAN, we will consider it as the VPN traffic, where users connect remotely and they get access to the services in the data center. So you have to define specific policies for LAN. Wireless is very a different history altogether. It is a different part. We need to have a dedicated wireless team for dealing with that. We have a WAN team. And if you are aware, and even if you are not aware, let me tell you, organization consists of different teams for managing different set of technologies. Now, first comes the LAN team. Next, you have the WAN team. Next, you have the security team. Next, you have the the perimeter security team. You have endpoint security team. There are so different types of teams. Again, I forgot there is a separate wireless team as well. In my recent organization experience, they had a separate team for managing the wireless part. Difficult, right? And again, adding resources to scale. Now, if you want to kind of add a new switch, it's a problem because you have to consider your architecture, which is actually built, and then include this switch into the current architecture, which means your current architecture changes a bit. Even if it changes for 1 or 2%, yes, you have a change. So you have to consider the policies on this router, this firewall, again these devices, the VLAN which are they have been configured for. You have to configure it on this switch as well. If it is, if it comes into the network, you have to at least make it trunk or access to allow this specific traffic to pass via that specific switch. Hectic, right? I'm sure it is very hectic, and for those specifically working in a knock background, it is very very hectic to manage this kind of networks. Unmatched demands on the network. Digitization. You can see, if you see the statistics, they have mentioned that 26 billion network devices in the world in the year of 2020. The number might have increased by 1 or 2 billion easily due to work from home in the last year in 2021. So we have a lack of business and IT insights. Now, what lack of business and IT insights? Just give me a minute quickly. Now, what does this mean exactly? It means we don't actually, in today's network, they are not concerned about what is the business requirement. They just know that we have to form a network wherein you have to your switch, you will have your router, and you have to connect it with the WAN. That's it. That is their requirement. They don't understand the business requirement is that every endpoint needs access to the internet. Some specific endpoints need access to the DMZ zone. Some specific assets should be kept very secure with no access to the internet. So this is the business requirement. Next issue, complexity. If you're not aware, let me tell you, in today's world, we are spending 5x cost on just the operations part, which is in business language, it is known as OPEX. We are spending 5x of the capex on just the OPEX. Like, for example, if you're spending 10 lakh rupees on implementing the network, you are spending 50 lakh rupees just to manage that network on this specific thing, network operations. And the ultimate concern of every organization is ultimately not met because it's a manual thing. You encounter daily, this is just a small figure, you encounter thousands of common threats daily, and they are increasing day by day. The number, the type of attacks which we are having nowadays, they are very sophisticated. Organizations, some of the small scale organizations don't even come to know that they were attacked if their data was breached. The attacks are those sophisticated nowadays. Traditional networks. Yes, anyone has any questions? I heard someone saying. Okay, no problem. Might be a mic issue. The traditional networks cannot keep up. Now, what does this means? Difficult to segment. Now, what is difficult to segment? For example, let's keep it to a standard example so it is easy to understand. We have employees in an organization. Let's consider an example of ABC Bank. Okay. And we have a kind of branch in Mumbai, or you can say very specifically in Bandra. Okay. And they have a kind of small setup. Now, the type of users they have is employees. Now, they also have contractors, which are like the company people who are managing their local area network, the WAN part, the SD-WAN part, whatever they have implemented. Then there are like some of the special privilege, or you can say higher management people who need like special privileges, special accounts, or special access. And we have different types of access list wherein the employees and contractors cannot speak to each other, the employees and higher management can speak to each other, kind of different ACLs, a set of ACLs. So a new employees comes. For example, I join a bank. And I am an employee. So for me to get into their network, they need to create my ID, assign a workstation to me, assign me to a specific VLAN, assign an IP address from their user subnet. Then if I have any special privileges, check if I belong to this higher management, I am just an employee. It is very difficult to segment this, right? And on top of that, they have different VLANs for managing the local servers because that runs the banking software or some of the local applications which are specific to this branch. So what is happening? The user and endpoint type is increasing. I get my Windows machine. I want access on my iPhone to the wireless network. Sometimes I even use my tab. Different device types, different VLANs, different subnets, right? And The ultimate thing is it becomes very complex to manage. We have multiple steps, multiple user credentials, one for logging into the network, one for logging into the server, the complex interactions, multiple touch points. This is nothing but the configuration parts which I have to do specific to my user. And when I start saying that I'm not able to, this is a very common, you can say, question by any person who is not of a IT background. Now, in this scenario, I am not an IT person, I am a pure banking person. So it means when I'm not able to access internet, I will just go and not say not able to access. This is the dialogue which you hear from most of them. I'm not able to see Google. I'm not able to open Google. What should I do? So this takes us to this point, slower issue resolution. Let's clear the screen. What happens? I have a separate user policy for me because I am in a user VLAN. Again, the type of user is wired. Then sometimes they don't find my user when they are troubleshooting. They have to run through a heavy list of access list and all that stuff. Difficult, right? Everyone agreeing on this point till now that yes, today's traditional networks have these problems. I'm sure 99% of them might agree, unless and until they have worked on the software defined part. Perfect. Let's jump ahead. Now comes the
Yeah,
solution.
I had a
Yep.
quick question. In terms of like different VLANs and different difficult to segment, as IPv6 gets more popular in the enterprise network,
Mhm.
I understand that ACLs will still be in play, but um, what is the impact of IPv6 on software defined access? I guess.
Software defined access is already ready to adapt with the IPv6. They have designed SDA like any SDN solution, keeping in mind that they have a crunch of the world is in a crunch of IP addresses, at least the public IP addresses. Because the concern is the public IP addresses, the private IP addresses, anyone can use any private available subnet specific to their organization. But when it comes to IPv6, these networks are designed considering this point that the world will be entirely migrating to IPv6 some or the other day within the next 5 or 10 years, you can say. Not fully, but at least partially, for sure.
Okay, thank you.
Yeah. So, introduction to software defined access. Ah, you see how clean it looks. The diagrams also look so clean compared to these specific diagrams. Sure, everyone might agree on this point. And it is because it is that segmented, that easy, and it is kind of sorted, you can say. Everything has been in such a nice place, it is designed in such a wonderful manner that yes, every specific device has been assigned a specific role which they have to deal with. Okay, let's get deep into what exactly a SD access, software defined access networks, looks like. The most important component, Cisco DNA Center. I changed the color because blue contradicts. Let's make it green because red, it looks very bright on red. This is the key component of Cisco's software defined network, Cisco DNA Center. Trust me, they are making every software defined network technology they have integrated with DNA Center because this is their heart of solution. DNA, the name itself suggests. Now in our body, everyone knows the DNA is the smallest component, but in this specific context of network or Cisco's network, it is digital network architecture, DNA. So what this looks like, the wonderful thing they have done is they've separated out the policy part. Whenever you see this fingerprint, just remember ICE is there in pictures. My favorite product. ICE is there in picture. Whenever you see this specific fingerprint, yes, ICE is a part of that specific network. Wow. See, the last domain to get automation, network. Probably everyone had automation in their domain, be it servers, be it security, be it database. Software already had it because they are the starting point who actually developed this. But automation, trust me guys, network is the last domain to get into automation. Until now, we are like 50 or 60% of them still organizations. I'm speaking from organizations perspective, not pointing any one of you. They're still doing the manual part, typing the access list, assigning users to a specific VLAN manually, logging into every switches. Come on, man, this is a world of automation. You don't have to do everything yourself. You just fire up the scripts, you just click some clicks, and yes, your work is done. And there is this part, assurance, which takes care of your where most of your money goes, troubleshooting part. Implementing is easy, troubleshooting is very difficult. Trust me. So this is how a software defined access network looks like. You deploy as many switches as you want, doesn't matter. Still, the cloud thing remains, which means the components are tightly intact into this network. You don't have to bother on the outside world because this is your campus, this is your requirement, this is what your business needs. Let's start with the most important point, identity based policy and segmentation. Now, can anyone tell me, for example, I know Vikas. So, how do I know Vikas? I know him by his name, or I know him with his address.
Via network homes.
Sorry?
Via network homes.
No, I'm not asking the medium. How can I like wait, let me get it clear. I understand that it is Vikas because of his name, right? I don't see that where he was born or what is his address is or what is his contact number. The important thing is his name, right? So considering a human, it is easy to recall a name rather than these things, right? Everyone agreeing on this? So the challenge which we had in the traditional network is we had to remember each and every user's VLAN and IP address. If there are multiple, see, if there are 2 or 3 VLANs, it is very easy to segregate the users. If there are 100 VLANs, you'll go mad remembering every user's VLAN and IP address. So this is when the identity based thing comes in, wherein you will be identified based on your identity. Name what just an example to focus on this identity based approach. And yes, so I can make it very easy that yes, Vikas is the owner of Networkers Home. You are the students. I am the trainer and there will be like trainers like me. See, already segmented. Not to worry on what is Vikas IP address, what devices are using, what are your IP addresses, what is my IP addresses, what is my location, again the type of device I'm using, everything solved into this part, into this single feature, identity based policy and segmentation. Let's jump on to automated network fabric. You see, a single fabric has, this is wireless, a single fabric has the wired connectivities. Now consider this IP camera. Obviously, they have to connect it by a wire. There are IP cameras who work on wireless, but it is recommended to connect it in a wired format. And to deploy this specific configuration, I'm using just a centralized hub. I don't need to log into this device. I don't need to log into this device. I don't need to go to the wireless controller to do these things. Nothing. This is my boss. I have to do everything here. And yes, he does the work for me. I don't have to worry how he does it. Simple, isn't it? And insights and telemetry, you might be seeing nowadays lots of artificial intelligence, machine learning stuff going in and out. Around the industry, everyone is trying to match up with this. Why this? Because you need to give experience to your users using the applications and the customers using the applications. So remember, this technology was built with a point in mind that the application, or to be very specific, the intent of what to do is important. So what to do is more important. What to do? Add a PC to the network rather than focusing on how to do. How to do? That's not my part. I just have to specify who will be using it. I am the user. I'll be using it. That's it. I'll be hooked up onto this network. You plug into any port, you are done. And again, since we have this thing, my identity follows me. I mean, the policy based on my identity follows me. So this part, see this part? Even if the user changes the floor. Now, if I'm in the networker's home building and I'm on the second floor and I jump onto the fourth floor, I don't have to check whether I have to connect to a switch or which wireless network they have a separate wireless network or not. Nothing. My identity is my policy. I change the floor, still I have the same level of access. I don't have to worry on that part.
So,
Because,
Pranav, I have a question here.
yeah, please. Your name?
Yeah, so Sujit,
Yeah, Sujit, go ahead.
well, my question is, so this technology is completely focusing on the endpoints, right? Endpoint nodes.
Perfect. Yes.
Right. So I was just thinking, we already have, SD-WAN technology, and why do we need something similar to that? Because topology looks very similar. Instead of Cisco DNA Center, we have the controllers when it comes to SD-WAN. So, so
The
this is,
managed controller.
that's right. So this is completely focusing on the endpoint nodes, right?
See, I'll short and sweet answer. ACI data center, SD-WAN for the WAN, the MPLS or the internet, basically connecting with this outside world. And SDA, campus, branch, or you answered it very correctly. You yourself answered your question. Endpoints. Keep this thing in mind. ACI is for data center. SD-WAN is for managing the outside thing, the WAN network. And SDA is for managing the internal branch. This is Cisco's idea of going forward with all the three domains. So yes, you said it very correctly, and a very important point. This is very endpoint specific technology.
Thank you, Pranav.
Yep, you're welcome.
This is Swami here. I have a question for you.
Yep.
I understand the piece with the wireless where mobility comes into picture. Like, you connect to your Wi-Fi network, you going from second to fourth floor, basically your user mobility with respect to that. But imagine you're a wired user and you connect from second floor to 14th floor, and then you plug in a cable into your network, right, into your laptop, for instance, and that is on a different VLAN tagging. So how does your username basically, so as soon as you log in, will it basically switch your VLAN and put you in the right VLAN space you're supposed to be on? Is that what you're saying?
So firstly, when you plug in your machine into a fourth floor switch, I am not assigned anything. The first and foremost thing they do is, first it checks my authenticity, whether I am actually the user. For example, this is my name and I was connected to the second floor switch, right? Now I'm going to the fourth floor switch and just connecting my device onto this, as we saw this, connecting on this switch. No VLAN, nothing will be assigned to me earlier. First and foremost thing, I will be authenticated. Based on my username and password, ICE is the answer which assigns me the right privileges and the right access which I had on the second floor. The same access is given to me on this floor as well. So the policy part, I don't have to worry. The authentication part, I don't have to worry. The rights and access or the VLAN part, I don't have to worry.
So Pranav, really quick. So essentially, what you're saying is when the laptop plugs into the full floor switch mode, right? Essentially, I guess there's ACLs that allow the laptop to directly talk to just the ICE policy. It's in a landing subnet, and then once the ICE validates the username and password, it then pushes the right VLAN tags to that switch port. Is that how it works?
Exactly.
Okay.
You're correct.
And Pranav,
And
if that's the case, let's say where different locations also follow the same policy, right? Let's say I'm from Bangalore and I'm going to, let's say, Mumbai. We have another branch. I'm going into that branch and I'm plugging in that device. So the same scenario should work out there as well, right?
the same scenario should work out, but there are different concepts known as different sites, wherein we have to establish the intra-site configuration, and that is kind of what you can say an advanced configuration which you have. Yes, the thing which you are saying is 100% possible. When you visit Mumbai for your meetings and you connect to your Mumbai office, obviously based on your identity, you should get the same level of access. This is what you're trying to say, right?
That's right. Irrespective of the location, if it is, looking at my identity.
Exactly. Yes, that is possible. That is possible.
All right.
Yes. Thank you. Any more questions related to this specific architecture? Should we jump ahead?
Sure.
Okay, thank you. This is kind of just like for kind of more image specific. I wanted to make it look nice. Innovation would be faster because of the insights and actions, because we know what everyone is doing into the network. We have a track of everything under the magnifying glass. The cost and complexity is reduced because we are using automation. Trust me, automation is a thing where you can make the human errors, because lot of problems nowadays are because of this. Because yes, we are humans, we tend to forget, we tend to misconfigure something. Yes, it shouldn't be habitual, but it happens. We cannot blame anyone. So the answer to that is just do this, and you don't have to depend. It's 0% human error. No worries, nothing. Ultimately, you're solving the complexity and the cost. And the most important thing, at least for me, is security and compliance. You have to comply with the organization policies, with the local authorities or the country laws, whatever it is, whatever you may call it. It is a different point altogether. But yes, compliance is very necessary, because compliance is a thing which keeps a track whether everyone is following the policies or not. So be it a network policy or an employee policy, based on the behavior. Compliance, you go anywhere, it is a mandatory. And again, security, because investing so much money and you don't have security, anyone can get access to your network from outside. That shouldn't be the case. So ultimately, these two things lower the risk. These things reduce the cost and complexity. And due to this thing, that is insights and actions, the network engineers or the NOC engineers should be kept happy, right? Because nowadays you have any issue, even if the application doesn't run. I know everyone might be having this in mind. I too have faced this. Even if it is application issue, what we are blamed is, no, it is a network issue, until and unless you present them the exact logs that no, my device is allowing this, or my device has the configuration which everyone has, which every port has. I'm not denying any specific port, so yes, it is not my problem. You have to prove that. So here, this thing helps you to get the proper logs, the insights, the pattern of how the network is. There's a lot of artificial intelligence and machine learning used in DNA Center. It's really amazing. We'll get into it in the later stage. Okay, so benefits, streamlined design. Now, what is streamlined design? This thing. This thing. See, everything is proper, streamlined. Simplified provisioning. Now, as we discussed on this point, if I want to add a specific network switch, the provisioning part, it will be quite a lot easy. We are going on that specific discussion soon, on what exactly are the components, what are the different options, what is the process which we have to follow when deploying a specific switch or to set up the entire network. We'll be dealing with that thing soon. the design provisioning, the important part, segmentation, how to segment, divide different users into different groups. Today we call it as a VLAN, but it is actually an identity based policy or an identity based segmentation. This is how it should be. The policy enforcement based on that, again the security posture, like my endpoint or the organization, the employees in my organization, whether they have this specific antivirus, is their machine rooted or not. Many of them nowadays don't like to follow the operating system. They root the mobile and then they use it, but it is dangerous to use such devices, whether that device is rooted or not. Everything will be checked in this policy enforcement. The
Sorry, what was that?
viruses,
Sorry, I
sorry,
didn't get that. The mobile is rooted. I don't understand what that means.
it means if you are using a rooted device, it would be harmful to the network, right? Because when a mobile network, when a mobile is rooted, you get full access to the system, right? The Android OS, you have a root access. You can install anything. You can even
Yeah.
install Windows apps on the mobile.
Yeah. So basically, in the Apple world, they call it jailbreaking. So it's the same
Jailbreaking,
thing.
exactly. Yes, you're right. They call it jailbreaking.
Okay.
So if my jailbroken device is connected to the network or not, everything can be checked in this policy enforcement part, handled by the co-leader of DNA Center, Identity Services Engine. Nice. And insights and telemetry, as we discussed, this is the raw data or the pattern of the users connecting, the types of devices connecting, or the different switches, how they behave. If we need any RMA of any specific device, if it goes down, everything will be taken care by the insights and telemetry, which is very specifically called as assurance in software defined access. Assurance. This, trust me, this is kind of has become a separate domain into software defined access nowadays. Clear with the benefits? Any questions, any doubts you have, you're free to ask, and I'll try my best to answer it.
Yeah, Pranav. So maybe I missed the first 2 minutes of the class, but did you go over exactly what topics you're covering in SDA and how long this course is? Seems like ICE is going to be playing a key role in understanding how it all works. Would you also be going through Cisco ICE as
Yes.
well?
Your name, please, because it's difficult to like understand whom I'm talking to. So if I know your name, I can refer and talk specifically. So may I know your name?
Yeah, this is Glenn.
Yeah. So Gwen, this is
It's
today's
Glenn,
lecture.
Glenn.
Glenn.
Yeah.
Okay, Glenn. I'm sorry for that. Glenn, today's session is kind of a demo lecture, or you can say just an overview session where you get to know like what exactly is the technology. But yes, a full-fledged course on this is available. And if you are enrolled for this detailed full-fledged course, we have a separate kind of in-depth topic relating to the identity services engine, its integration with DNA Center, what is the exact workflow, how it works. Yes, everything will be taken care. Did I answer your question?
Yeah, you answered my second. Yeah, you answered my second part. The first part is how long is that course? I am enrolled with the program, so I'm just curious to know how long this course is going to take, and is it going to be in the same time zone as today?
I think for that you have to contact Vikas.
Okay.
Yeah, he may guide you better on that part rather than me.
Okay.
Yeah, it should be around 40 hours. What I have seen, the content guidelines and everything else, and what Pranav has sent me. So it should be around 30 to 40 hours is what it is. And then there should be an ICE training. And that depends, it doesn't require much of an ICE expertise, but you need to have a brief idea, and at least one lab has to be done on ICE also. So put it all around 40 hours is good enough.
Yes.
Pranav, next class, can you please share the whole syllabus with the team in the PPT so that they can see what are the topics, the total topics that we are going to cover?
Perfect. I'll do that. Not a problem. Just to keep it for today's session, I kept it very specific. The modules for today's session. I'll share that. Not a problem for me.
Yeah, thank you.
Thank you. Any more questions? Should we go ahead? Okay, I'll take it as a yes. So Cisco's intent-based networking. I know many of you are currently enrolled for the SD-WAN part, and here you see this is what you are learning now. Not now in the SD-WAN section. Now we are learning this part. And we have again a separate world for this. Recollect me saying sometime before that the data center is all about ACI, the WAN and the
Pranav,
branch.
one
Yep.
doubt, one question I have.
Yeah.
When I look at the Cisco SD-WAN licensing, they don't have separate SD-WAN license. They have it as Cisco DNA Center with SD-WAN features, right? They have essential advantage,
Essential
and
advantage,
something else.
right.
So is it actually part of the bucket of SD DNA or SD access?
It is actually they have like made it all under this roof, DNA Center. Everything they have
Right.
made, the Cisco One software, they have all aligned with the software defined, so that, for example, if you buy a specific network device, like consider a Catalyst 9K, any series, and you have to order it with the licensing schema. So consider you ordered it with the advantage license. So it is covered in this Cisco One software strategy. So everything supported in this Cisco One strategy, you can use that device into SD access. If it supports ACI, you can even use that, because there are specific devices which even support integration with ACI, or using the same device, reusing the same device with ACI. And there are some devices which can work well as a VH router, also as a edge device in SD access. And also I don't recollect the terminology from ACI. It is called as no, I don't know
Leaf.
the
Leaf.
leaf. Sorry, leaf. You can make it as a leaf in ACI. So they've made it more centralized. They are making everything centralized. If you see at this technology as well, they are like trying to do everything from the DNA center rather than going hop by hop on every device and doing it individually. So the software, the what you can say, the licensing thing also, they have made it quite similar. Okay, so intent-based network. Now you see all the technologies having software defined thing, they have named it under this roof, intent-based networking. Now what intent means, that what I have to do. The meaning of intent is what I intend to do. Example, I intend to play, which means I want to play, right? In this language, in the world of Cisco, it is I have the intent of adding a network device to this specific fabric. Yes, you just have to express your intent. This thing does the part. You don't have to worry on that part, how part. So that's the meaning of intent-based network. You just have to specify what you want, and how it will be done, it is taken care by the network. Earlier,
So basically that means that there are predefined templates available, right? A lot of feature stuff is already ready.
exactly.
And
Like for example, just to give an example, because for example, there are 24 ports on a switch. Now, what we do, if we have 24 users, we configure each specific port manually, right? By going into switch port mode access, switch port access
yes,
VLAN. The same thing is done, but we don't do it. It is the template which does it. So if I have to make it trunk, there is a trunk template. If I want to enable no, this is advanced thing. .1x on any port, it has a template. If I want to make it as a access port with kind of allowing only the employees you can see. So which means the underlying thing remains the same, but you don't deal with it individually. You just have to specify that who will be accessing it. Employees will be connecting on that port, contractors will be connecting on that port, or who will be connecting, and it will be taken care by DNA Center. So it is again a template. They have made it like SD-WAN also. I understand that it is more of a template based thing wherein you just throw them with the what you can say parameters, and the vManager or the SD-WAN controller does it. Same thing here. You just specify what you want, who wants to connect on that port. This thing does it. Don't have to
So,
worry on that part.
if I connect it to SD-WAN, how we basically work is that you choose which vEdge or which router do you want to apply a policy, on which interface you want to apply the policy, what is the policy, you create a template. Here in SD-Access, what happens is generally you have the LAN access switches, and so you decide which switch you want to do something and on which port you want to do something, and you apply the template exactly same that you do in SD-WAN here also. And because on the LAN side, you integrate with ICE, you integrate with so many other things. So the scope of the feature is more.
Exactly, because here in a LAN based thing, you have to consider the security, you have to consider the access part, like whether they need access to a specific resource, like this thing has to talk to this or not. This thing has to, in a return direction, has to talk or not. Whether this
Right.
can access this, whether
And a
wireless can access
lot of
wired.
a lot of ease of configuration in terms of
Exactly.
VLANs will be removed and VNs will be added, right?
Yes,
So
it is. It is
the
very
policy is detached from VLANs and added to VNs, another thing, so that the user is in any branch, any site in the world, right? He is not bound to any physical thing. He's bound to his particular policies.
exactly. He is bound to his identity. He proves his identity, and the policy will get applied.
Right.
Okay, so this was all about intent-based network, all these three technologies. That's the reason I have put like I have used this diagram so that you get a whole lot of big picture. This is the big picture, and we are dealing with this specific piece of that whole lot of like big picture. This is the software defined access. We have the course, like the coming course will be very detailed. We will be covering all the VNs, virtual network, the security group tags, the segmentation part, the trust sec, how we can identify the user, or what configuration will be pushed. Everything will be discussed in a brief manner, just because not to confuse on the day one itself. I've kept it sweet and simple, so you just get an overview of what the technology is rather than getting into the complex terms and terminologies on the first day itself. First
Yeah,
you know what this is, and then later on you have a chance to explore the world of this.
yeah. Pranav, a couple of questions, maybe too early, but maybe you can answer them.
No
Does
problem.
this will this course prepare us for any exam? That's question number one. And then question number two, security group tags. Is that connected to VXLANs and stuff?
No, no.
Okay.
SGT is micro segmentation. VXLAN is a complete different topic, which is like you can have more segmentation on the network. Like for example, VLAN had the limitation of 4096. In VXLAN, it is all about tunneling. Like if this thing wants to talk to this thing, it's a VXLAN tunnel. In VLAN, we didn't have anything such. We just checked if this is VLAN 4, yes, this can talk to this. So
Got it.
VXLAN is basically the tunneling part. wherein the intercommunication will be taken care. The communication part will be taken care, and the data plane will be taken care, to be very specific. And
Okay.
about the first question, yes, uh, in the routing switching or the data center part, I'll have to check the exact exam code, but yes, SDA is a part of one of the certifications. I'm not sure because I'm more into the security part, so I'll check and get back to you in the next session on the certification part, that
Yeah,
which certification. Yep.
yeah, that's fine. And then is security group tags, is that a Cisco proprietary mechanism? Meaning, can I install, you know, I guess first one is, can I do Cisco Meraki and connect that to, the DNA center and have SGTs propagated through Meraki Wi-Fi access points?
You have to check whether Meraki is compatible or not with the SGTs. Now, the thing is, regarding this compatibility, Cisco's switches are the ASIC or the hardware is made very specific to support SGTs. Now, you might have a question again that what if there are old devices who don't have compatibility with SGT? So there is something known as IP to SGT mapping, where you have to do it manually because your hardware doesn't support it. So you have to do this mapping manually. So if Meraki supports it, the propagation of SGTs, yes, it can be a part of this DNA. But if it doesn't, you have to use this thing, IP to SGT mapping.
It does support, Pranav, it does support SGTF.
Perfect, because I'm not like not more into the Meraki part, so I'm unaware of that. So yes, if it does, then perfect, we can use this.
Okay, and it gets pushed via ICE, correct?
Yes, the propagator will be ICE. The ICE will be the platform where we'll be configuring all the SGT part.
Got it. And then will ICE also be the platform to do the IP to SGT conversion
Exactly.
in case
Yes.
via AAA override, in case, certain equipment is not SGT compatible, like you mentioned?
Yes. So what you do is on ICE, you have to do a IP to SGT mapping, and on the network device, what you do is you fetch this specific from the AAA server or the ICE. And yes,
Got it.
this IP to SGT mapping gets downloaded onto that specific network device. Same as
Okay.
same as the normal SGTs are downloaded.
Okay, thank you.
Okay.
What is SG security group tagging? Is that what it is? SGT?
Yes, security group tagging. Don't worry, will be the fundamentals relating to this specific technology, SD-Access, whatever it is, SGT TrustSec. We will be having at least an overview so that you are not completely new to that technology. We'll first be having a look of what this technology is about, and then only we'll be jumping into the micro segmentation part. Because
Okay, so
without
you
knowing the SGT, it is of no
yeah,
use to learn.
right. So you'll be covering that, right? Okay, got it.
Yes, but just an overview, not a deeper view, because SGT is kind of just the SGT part is used for the micro segmentation, but the entire like trusted configuration has to be done on the ICE. So what is specific to DNA Center, that will be covered. But for a detailed course, we also are planning, or already I have the ICE course as well, wherein you'll have this specific thing covered relating to the ICE, because the trustsec part is taken care by ICE. The mapping and everything, the matrix, we have to do it on ICE. It can be done on the network devices as well, but that is kind of a lot of, again, the same thing. You have to do it manually when you
Right.
have
So
a
that's a
AAA server.
core ICE topic. In fact, DNA Center is
Yes.
just used to push the policies. You don't create policies here, especially related to security. You rely
Yes.
on Cisco ICE.
Yes, and ICE, like you must have heard about that PX grid protocol. It converts that into DNA specific language and pushes it onto the devices. So like DNA and ICE are tightly integrated in this solution. So whatever you do here, it is available on the DNA Center. The terminologies may change, but the actual concept or the actual thing remains the same.
Okay,
So
excellent. And Pranav, the reason for having you as a master of this class, as a trainer of this class, is that the kind of experience you have on the security, right, and the kind of background you have in terms of your education is from one of the most premium engineering colleges, BITS, right? And
Yes,
then
bit film.
you have a solid experience, hands-on 6-year experience on ICE and SD-Access, doing hands-on for a top Indian company. And then you planned that I want to go further and I want to enhance my knowledge. I want to go to Canada, and you got admission
Right.
for your master's program, which you're doing right now, right?
Right.
So we have a lot of expectation in terms of, share us a lot of practical knowledge, the industry's knowledge.
100%, because just what you can say, an eye opener. Don't judge me on this. This thing, the easy it looks, the complex it becomes. Trust me, we have like it has a lot of components because it is an entire new world. This thing is an entire new world to the network domain. Until now, we are just used the switches, the three-tier architecture, the VLANs, the IP addresses. We are just used to that. But trust me, this has got a whole new bunch of things. Like you'll find everything new in this. It is like completely revamped. Everything is revamped. Right from where the routing table is, where the mapping is done, which endpoint connects on which device, the ARP history, everything is changed. Everything they have changed. So yes, we have a lot coming on this course. We will be having a detailed sessions, and I'm worried if the time would permit us, but I will try to make sure that we cover the most in the 40 hours session, like the full-fledged course.
Yeah, hello.
Yes.
Hello, Pranav or Vikas, can any one of you can answer my couple of questions actually. Let me introduce myself. My name is Prithviraj. Okay, I have joined NH a year back almost actually. So I'm working as a datacom test engineer in a reputed company. So my doubts are like, so what is the minimum? I mean, prerequisite for the taking this course? And mainly my work area is routing and switching part. So is this will be useful for those, or we need to go for any other kind of domain knowledge? I mean, say for example, you can understand, right? So my role will be a different one if I take. So how it will be helpful, and what are the prerequisites for these things? These are my doubts actually.
Okay.
Okay, can you please tell me which program are you enrolled into?
Because my is CCNP Enterprise actually. First I have
CCNP.
resigned, yeah, CCNA. Later, after completion, is CCNP Enterprise.
Okay, it's in fact is a part of CCNP also now. And what happens is SD-WAN and SD-Access, these two technologies today can take you to a different level of jobs in the market, because the market for these two new technologies is huge. And in terms of the upgradation and money also, this will be a huge advantage to anybody who learns these two technologies, because all large MNC companies, see, if you are working for a company which is still on the old technologies, right?
Yeah.
If you try to move to a large company like HP or Cisco or anybody else, right, where the big money is, they will actually require people on these technologies rather than the routing and switching, because that's almost gone from all the bigger campuses these days.
Perfect.
Okay. Okay. So what you're saying is SD-WAN, and this topics also will cover and CCNP Enterprise also, right? That's what
SD-WAN classes are going on. It's almost now 3 classes left, but you can enroll into next one also. But yes, as far as the CCNP is concerned, the program has it, but what we are trying to achieve with Pranav here is CCI level content here, and basically, correlating it to a bigger topology and all that, which will come after this training is over. We are going to add it to SD-WAN and do a lot of labbing and all that. So basically, 90% of the students in this batch are the one who have enrolled for CCI with us.
Sure. Okay. Okay. Thank you. Thank you for clarification, Vikas and Pranav.
Yeah, no problem. Okay, so speaking of SDA as an intent-based network, so just an high-level overview. If you see, the first step is here. Capture the business intent. We have to convert it or translate it into the policies and check the integrity. But it is not we who will be doing it. It is the technology which will be doing it. We have to just specify the intent, as we discussed with a very practical example, that for I want to this specific set of ports to be configured for this specific set of users. I have to just select the ports and put it and specify that which type of users are connecting. That's it. It'll all do the configuration. I don't need to worry. So either it will be using a template, or is it using actual like the manual kind of thing on a switch by switch basis. We'll be having a look in a detailed part later. But yes, when we are doing it in bulk, it will be most of the times a template based, because it is easy and it is more, or you can say less prone to errors when we use a template. The next thing is orchestrate policies and configure system. Now, orchestrate means you have to, it will be identified which all devices, like if it is wireless, the access point comes into picture, the switch where the access point is connected, it comes into picture, the wireless controller comes into the picture. So the DNA center orchestrates the policies and configures these physical infrastructure accordingly, whatever is a part of the SDA fabric. And on top of that, the most important thing related to the troubleshooting part is the verification of the configuration and a deep visibility that who all are connected, what device they have, what IP addresses assigned to them. Now, even if we are not dealing with very IP specific, a network administrator has to have the information of the IP addresses. Even if we are not configuring based on the VLAN, there is some kind of ID assigned to that specific we need to have. Now, think this from a network administrator point of view rather than from a customer point of view. The customer will not look into these things, but a network admin will look into these things, but in SDA context, it will be related to the identity. And the magic of DNA center is it even suggests the corrective actions. Like for example, if you say if any policy is blocking, it says yes, a policy is configured incorrectly, or you have did a misconfiguration on the DNA center itself, which is blocking your traffic. So that level of insight and visibility we have in this specific technology. And everything is done by this specific solution. So SDA is an intent-based. See, let me be clear. Intent-based network is not a thing which is made by Cisco. Intent-based network is a type of network wherein just the intent is specified. And all the SDN solutions, the most popular ones, are following this specific approach. So obviously, Cisco is also a world leading organization with network and security solutions. So SDA also follows the same approach, which is intent-based network. Here.
Like whatever you feel like doing, that is possible through SDA. Is that what it means?
Not everything what you feel, it also has limitations, but whatever you used to do earlier in the traditional network, a lot more can be done as compared.
Oh, okay.
Yep. This is just a example. Intent. I need to scale out my application database. So in manual thing, what exactly is done? You extend the network segments. The load balancer configuration is updated because you are scaling the database. So you're adding more SQL servers to that. The QoS policies, the quality of service needs to be taken care. So these all things will be executed when I just specify the intent. Don't look at a kind of what you can say configuration point of view. Understand why this specific solution and how it is a intent based network solution, rather than relating this on a configuration basis. Relate it on a very high level so that you understand why this specific solution was designed. Vamsi just will finish this and I'll answer your questions in the chat. Another intent. I have scheduled a telemedicine session at 10 a.m. or you have an appointment. So what it is, create a SD connection, prioritize with QoS, validate the performance, keep the communication safe, tear down connection after the call. Now this example, you can say like a very general example, but the intent is to attend this session without any interruption, without any problem. So this all things have to be executed in the backend so that the intent is achieved. I'm rolling out a new IoT app for factory equipment monitoring. So what all has to be executed? A new segment, entire altogether IoT segment has to be created for all the IoT devices which are connected in the factory, which are connected in the headquarters, whatever it is. See, create a new segment for all factory devices to connect to the IoT app. The important thing, isolate it with the general network traffic because IoT devices are more vulnerable to attacks. Many of the attackers choose the IoT section to attack organizations because they are more prone to errors. Their software have more vulnerabilities and it is quite easy because that thing is that IoT device is connected to the network, and when it is connected to the network, obviously it has a connection with the network. So using that IoT as a threat vector, we can get inside the network using that specific IoT app as a threat vector, that software as a threat vector. I need to deploy a secure multi-tier application. So for this, we have to provision multiple networks and subnets. The configure ACL and firewall rules for allowing it from outside DMZ or whatever zones you have, and advertise the routing information to the entire network so that we know that this specific application sits on which server and everyone is able to access it. So I love this line. With an intent-based network, the administrator determines the what and the system then figures out the how. So this is what an intent-based network's definition is, that it focuses on what has to be done rather on focusing how it will be done. Okay, so Vamsi is asking, I just wanted to know what is the basic hardware and iOS requirement to implement SDN. Is there any document that we can refer to and apply in real time? So Vamsi, for implementing SDN, now keep in mind, you have to be very specific. SDN is a general term. SD-Access is actually the term which we will be dealing in our course. For Vikas, it will be SD-WAN, the very specific technology which falls under SDN. And if we have a ACI course later, it will be application centric infrastructure for data center, which will be a SDN solution. So you have to specify. So next time when you think of the hardware and iOS requirement, you have to keep in mind that what exactly you have to do. You want to implement a campus network, you want to implement the WAN network, or you want to implement the data center. For speaking with your question, relating it to the SD access, yes, we have a hardware and iOS requirement for SD access. And yes, that document will also be, it will be also a part of the training, wherein we'll be checking on the hardware components which support the different kinds of roles and terminologies of the devices, and those specific devices can be interchanged and used as well. Like there are multiple models in the Catalyst 9K family, wherein you can use those devices for a specific role. Okay, you're welcome.
Hi Pranab, this is Saurabh.
Yep.
So will you be covering all the topics like design policy, provision assurance, and platform in detail?
Yes, because that is the core part, the
Core part,
design. Yes.
right. And the policy assurance platform will
Yes,
cover all
the
these things.
SDA is nothing without those 4 options.
Right. Okay. And there is something called network devices and Cisco DNA licensed devices. What's the difference between those two terms?
So the licenses are more specific. To be more specific, it is a network essentials license, wherein you get a limited functionality, and it is kind of a license which you get for a normal traditional network. But to use this specific software defined, what you can say, terminologies, or to integrate it with this technology or with the DNA center, you need to have the advantage license. So when you have that advantage license into that device, you can utilize that device for making it a part of SDA fabric.
Okay.
So this is the actual SD-Access architecture. Now let's dive a bit deep into it. Before jumping onto this, keep in mind it is divided into 2 different parts. One is SD-Access. One is SD-Access, which deals with all the configuration and everything of these devices, the software defined part. And there is a campus fabric which deals with the control plane, data plane, policy plane. So these 2 are different terms. Campus fabric is built with the help of SD-Access. So if you see, SD-Access is nothing but a GUI approach, wherein you log into the DNA center and you do all the automation part, the policies part, the group-based policies, who has to access what, who is permitted to communicate with whom. Everything is done within this SD-Access, which can be or not can be, which is done in the DNA center. Remember, when deploying a Cisco DNA Center, it is not mandatory to implement SD-Access. You can implement DNA Center only for the automation and assurance as well. Like for example, if you have a couple of thousand switches and you are like fed up or tired of pushing the DNS servers, the SNMP servers, the syslog servers onto those specific devices, but you don't have the budget to implement SD-Access, what you can do is you can simply deploy just the DNA center for the automation part. Yes, you have the feasibility as well, like just to do that specific part. So that will be an entire traditional network. You just are using DNA center for this automation, so that you just create different sites, add these devices, and push this configuration directly. Yes, this is also achievable. And
Yeah.
DNA center is also available just for the assurance piece.
Excuse me, Pranav.
Yep.
So,
Yep, Glenn.
so when you look at the DNA center, just using that as a method to push to your traditional switch networks, you just get the base license, correct?
Exactly.
Okay. But then if you want to start implementing SD-Access, would that be the second tier license? And what's that called? Advantage or something?
Yes, that is advantage license. And when you are implementing a traditional network to a software defined access network, you cannot take this entire traditional network in day one onto SDN network. You need to plan a kind of migration thing wherein you have to plan a strategy, what devices are less impacted, what are the downtimes you have, which specific devices are the core heart of this specific technology, which has to be in place. Because without having the core devices, obviously without a core switch, the L2 switch is nothing. So in the same manner, first we have to implement the core devices and then bring in the access part into it. Again, on top of there is a parallel migration approach, there is an integrated migration approach wherein you revamp the existing devices into the SD access nodes, or if your business is quite critical to applications, you build a separate parallel network, which on a downtime you shut one of these and take this up. So there are different migration approaches. I have done migrations of various organizations from, like you can say, traditional to software defined access, because it is very less you'll encounter that some new organization has come up and they have planned that their direct greenfield network approach as the SD access. First, everyone goes to the traditional, every organization already has a network setup already, and then more of it you can call it as a brownfield migration rather than the greenfield implementation. It
Correct.
will be a migration.
And you'll be going through those different strategies, migration strategies as well,
Yes,
right?
and I'll be also narrating my experience with one of the largest bank of India, not the largest, the only government bank of India which deals with all the monetary funds and everything, and what challenges we faced, what was the approximate tenure required to complete that specific project, and like I'll be telling both from the customer point of view what were the expectation and what were the challenges they thought, and what were the challenges which we had to meet their expectations. That will basically be the last class, but it will be more fruitful when you know these kind of experiences.
Yeah, makes sense. Thank you.
Thank you.
Pranav, this DNA center you're talking about, right? Like where you said you could use only part of that feature, the automation, if you need another assurance. So are we talking about, is it like a hardware device, this DNA center, or is it like
Yes,
something like a
DNA center.
vManage?
A DNA center is a hardware device. Till date, I'm not sure, but yes, DNA center is not available virtually as of now. You have three boxes wherein you have to. We will be discussing it in the today's session as well. At the last part, we have that specific thing relating to the DNA center. That what is the hardware, what is the capability. We'll be discussing it.
All
Just
right.
hold
Yeah.
on for
Thanks.
a few time. We'll be on that.
Okay.
So, discussing on this part, the most important component of SD architecture is the DNA center. The next part is ICE, which deals with the policy part. Now, if you see the CLI or API approach to build a Lisp VXLAN CTS fabric. Now, what is Lisp? Lisp is basically the control plane communication. I'm telling it on a very high level overview. We will be dealing it in a very detailed fashion, even the packet flow as well, that how the packet flows from here to here to here for going out. So don't worry on that part. CTS fabric is the, sorry, CTS, not CTS fabric, it is CTS. CTS is basically the Cisco TrustSec, which deals with the micro segmentation part to be specific. And for box by box configuration, which is done by the DNA center itself, we use this technology, netconf or yang.
Yeah, Pranav, I had two questions. Can you one more time explain what microsegmentation means in an enterprise network? And the
Okay.
second thing is API provides device automation via netconf and Yang. Is that different from REST APIs?
This API is what you call a REST API, and these are the flavors of API, netconf and Ang, which is used specifically by the DNA Center for the automation in SDA architecture.
Okay.
So you can do the RESTful part as well by yourself. They provide a capability to use the RESTful APIs by yourself. But for this box by box automation, DNA Center prefers netconf and Yang.
So they're
And
two separate things. Netconf and Yang are two separate things, or they, interchangeably used to the same names?
These are the protocols.
Okay, I know that we are using netconf and SD-WAN as well. So I just want to know, so it's going to be the same, right? What we use in SD-Access and in that.
Yes. It's Cisco, so it's obvious the same.
Oh, okay. It's okay.
Yes.
Okay. And a second question is, so basically the Lisp and the VXLAN, right? We aren't aware of those concepts. So you'll be touching those, right? When you actually go through those.
Yes. Lisp will be the control plane. VXLAN will be the data plane. I'll be touch basing that as well.
Okay. Yeah. Thank you.
Yep. Glenn, your question about the segmentation. In an enterprise network, there are two things when it comes to SDA architecture: macro segmentation and micro segmentation. So the TrustSec or the HGT part deals with the micro segmentation, and the macro segmentation is more of a, you can say, VRF thing, wherein you have different instances of routers running on a specific router, so that the routing table, the entire thing is separate. One is not aware of the other, just to keep isolated traffic. Example, guest network. You don't want your guests to interfere into your campus network and know what exactly is running. A guest may be an intruder as well, right? So this is where macro segmentation comes into picture. Micro segmentation, you have employees, you have contractors, you have different set of servers, you have access points. You don't want every one of them to communicate with each other. You think some of them may have any bugs, and anyone can put any script into a specific device and get all the information. You don't want that thing to do. So again, micro segmentation. Use specific tags.
Yes, I guess that's why I'm a little bit confused, because in an enterprise network, they have a guest wireless network, right? A guest Wi-Fi network. The guest user connects to that guest SSID, and now he's
Exactly.
on the
They
network.
get a separate portal. They have a separate set of IP addressing schema.
Yes,
So
ACL is
basically, you can
different.
call it, they have a separate kind of network architecture.
Correct. And that's macro in terms of SD access, right?
Exactly. In SD access, it is macro, but inside a specific organization, now consider the LAN part, the LAN VN. When you have a LAN virtual network, it will be further micro segmented. And LAN and guest are my macro segments, the bigger versions, the VRF kind of thing.
Okay, thank you.
Yeah. So this is all about the campus fabric. Let's quickly jump on to the high level overview of the fabric rules. So if you see, as we discussed, DNA Center comprises of these three things. I don't know why my stylus is using a different color. 1 second. ICE, which is the identity services engine for managing the identity services or the policy part. Cisco DNA Center comprises of this thing, NCP, which is network configuration, which is done using the automation. It also has the assurance engine, which is popularly known as network data platform, NDP, network data platform, which takes care of the assurance, the insights, what issues are there in the network, are there any port blockings, are there any existing ACLs which are blocking the traffic. Now comes the important node, which is the fabric border node. Now this is a very important terminology in SD-Access, because this is the entry and exit point you can see. So the gate of your home, it is this border node. You come inside via the border node and you use the border node to exit the network. The next important piece, control plane node. It keeps all information of where every endpoint is connected. Example, I am connected on port 3. As soon as I plug into this, no one but the control plane is first notified that I am connected on port 3. The intermediate nodes, these are just for the internet networking. If you have a large scale SD-Access network, just if the border node doesn't have those many ports, we connect it to the kind of distribution nodes, you can say. Not they do. Remember, the distribution nodes in the traditional network play some role in these things. These intermediate nodes are just for connecting this. That's it. Nothing else.
But can you just repeat it again, please? I didn't understand what you said. Sorry.
Oh, okay. The fabric border nodes are the nodes which connect the fabric with the outside world. So to get inside a fabric, or to get outside the fabric, for an endpoint to get outside the fabric, it is the border nodes which deal with this thing. So to connect with the outside world, you have to do the configuration on the border nodes. To connect it with the DNA center, you have to do it with the border nodes. So these, as I said, is the gate which deals with the entry and exit.
Yeah. So Pranav,
So
can you
they are
give some-
essentially router, right?
Yeah, they're routers. They're routers.
Okay, is it routers and firewalls together? Because
No,
usually,
no. It to be very specific, those are Catalyst 9K L3 switches working as a border node. The terminology is different, and the switch hardware, we will be discussing it in the later part, what all it is supporting. So those are nothing but the Catalyst 9K family of switches, access switches, which are supporting this SD-Access architecture and which act as a border node. There are specific models which deal with this specific, which can be enabled for this border node functionality. These are the intermediate nodes which are used just for the purpose of connecting the border with a lot of access nodes if you have a lot of them. Else, the like you can directly connect fabric edge nodes with the border nodes. Fabric edge node, this is your leaf. You can say any endpoint, it has to connect to the edge nodes, nothing else. You cannot connect your endpoint with any of this. Any endpoint, be it any kind of like wireless, wired, anything, it has to go to this. Even the access point, it either connects to this or you have kind of extended node kind of thing. But yes, every traffic coming from the endpoint comes from the access node only, nothing else.
it almost looks like a core distribution access layer, right? Is it
Exactly.
Okay.
Just the naming conventions have been changed, and the way in which they work, that has been changed.
Pranav, these B fabric border nodes are at least 9,000, right?
Yes,
And even the control plane node is the Catalyst 9,000.
this
That's
is the
connecting the
9,000.
wireless.
This is the 9,000. This is the 9,000. Everything 9,000.
Okay, 92, 98, all this.
Yes.
Pranav, just a quick question, man. So when you say leaves in respect to SDA, these are again layer 2 devices, right? Because if we go to an ACI and you say a leaf, then it would be a Nexus device there, right? That would be
I just referred to the word leaf for
Okay.
a better understanding. There's nothing known
Fine.
as leaf in SDA. It is fabric edge nodes.
Okay, gotcha.
Because in ACI, leaf is the device where all the endpoints or the servers connect. So in SDA, edge nodes are the devices where all the endpoints connect.
All right, got it. Thank you.
Yeah. One more thing, there is no L2 in SD-Access. The sweetest part, everything L3. Sounds interesting?
You didn't touch on the control plane node. So what exactly is the functionality? Because
I'm coming on that part. I'm coming on that part.
Okay,
I'm going this way. So we came to know what is a border node. We now know, at least we know what the use is. There is a detailed configuration part as well. There's a lot of things. The edge nodes, we know that the endpoints connect on the edge nodes. Control plane nodes. This control plane node, let me tell you, can anyone answer this question just like so you have a better understanding? Where is the endpoint mapping or the what you can say the R details or whatever you call it in the traditional network is stored in? All this data is present on the core switch, right? The core L3 switch. In SD-Access, you have a dedicated node, control plane node, which is the brain, you can say, which actually has the information that who is connected where.
So he is the V-smart of this thing, right? He has
Right,
all the information there.
exactly. Let me tell you again, they have designed it in such a nice way that this control plane node, now even if in the topology it is shown as a separate thing, you can make this as a B/CP. So the same node works as a border, as the gate, and the same node works as the control plane node, which has information of all the devices connected, and this information is complete real time. You disconnect from a specific port, this node comes to know that you have disconnected.
Okay, so Lisp is the protocol for that, right?
Lisp is the control plane protocol, and VXLAN is the data plane protocol, and CTS is the policy plane protocol, the Cisco TrustSec.
Okay, okay.
So this is CTS. This is control plane with Lisp, and this data plane is VXLAN, the underlying protocols. Now coming on to the wireless part, there is a fabric wireless controller.
It means,
Yeah.
hello, are you getting my
Yes.
voice?
Yes. You're audible.
Mahendra this side. It means CTS, by the CTS, ICE will be connected with all the leaves devices, right? Via tunnel.
Sorry, come again.
Means CTS, it's a feature that ICE directly connected with the leaves, right?
It is it is not directly connected. It propagates the tag for assigning it a identity or assigning it a group for segmentation. So Cisco TrustSec is basically a protocol, or you can say a method in which ICE propagates the tag information to the endpoints that this device belongs to an employee, this device belongs to an contractor, this is a data center server, or this is a local server, this is an access point.
Means when a device we will connect, immediately it will sense via the CTS, right?
Not via CTS, it comes, CTS is a whole different story. CTS is used for assigning a tag. It is the .1x protocol, which is used for the authentication, wherein if a device connects to a network, it will go to the authentication for ICE. then ICE will look up either with the AD for the credentials, or if it is like a MAC address thing, so it will look for the MAC address table into its database which we have added, and then it will tell that yes, you are authenticated and you have access to network. Later stage, when we have to decide whether this employee can communicate to this contractor or not, this is the time the policy based decision will be made by CTS, but this traffic will actually be dealt by VXLAN. So the data plane is VXLAN, policy plane is the CTS, and this thing is the Lisp.
Okay, fine, got it.
Okay, so coming on to the wireless part, this is the
Pranav, one
wireless.
question.
Yep, go ahead.
That particular policy, will that be downloaded to each and every Fabric Edge node?
Yes, it will be
When
downloaded. A very good question. It will be downloaded onto the CTS policy is downloaded onto every edge device, because you, with this solution you need to have mobility. So if I am connected on second floor, as we discussed, I disconnected, I go to the fourth floor. So if I am on the fourth floor, this switch has to know that who I am. So it ICE has already pushed that specific policy on this device as well. If I connect on the third floor, this already has this. If I'm on the first floor, this already has it. So no matter where you connect, the policy follows you. Did I answer your question?
Yes, thanks.
Okay.
But that would increase the CPU and the memory utilization on every edge node, right?
That's the reason we are using Catalyst 9K. They are designed in such a fashion to handle all this traffic coming from ICE.
Okay.
Yep.
Sorry, where are we using Catalyst 9K? On the Fabric Edge node you're talking about?
Edge node, border nodes, control plane nodes, everything is Catalyst 9K.
So,
I
the
think
users.
9K have a capability for the SDN, right?
Yes.
Okay.
Okay, so your edge node, when you say Fabric Edge node, that's a Catalyst 9K. So basically your end users are connected to this Catalyst 9K?
Yes, your end users are connected to this Catalyst 9K switch, which is known as the edge node in SD language.
Oh, okay. So I mean, I'm not understanding why is there control. So you're telling that the ARP table is stored in the control plane node, but not in the edge node. Why would a switch, like if a device is discovered in Fabric Edge node, why is the ARP table stored in control plane node?
Not specifically ARP table, but this is a centralized CPU which has all the information. Now, it is very obvious that when you connect a specific endpoint to this device already knows, because it is itself on which the endpoint is connected. But to keep a central track which is like easy for establishing the VXLAN tunnels, this thing gets a copy of that. And this is the, see, I'll tell you, in SDA, this anything connects on this thing will first go and update to the control plane node.
So can we say
Everything-
it's like a rendezvous point? Is that right?
Yes, in multicast you call it as rendezvous point, and yes, you can say like control plane node gets the information first, it updates its database, because this you can call it more in a general, but I'll tell you a layman term, this is the facilitator. So if this switch
Pranav,
comes
I'll
and
try
says,
to, let me give another example here. Can we call it like a DNS server where the nodes don't need to know the whole world's DNS table? You want to resolve a IP, right? You just go to a DNS, you say somebody types yahoo.com. Now imagine that if you are on the Fabric Edge nodes and you have billions of website namings all loaded to you.
right,
right? So
The-
the purpose of Lisp is to have all the database, and it's an on-demand basis that it supplies. So A wants to talk to B, A will go to the control node, will ask for the MAC address or the ARP entry for him, and then A will be able to talk to B. That is also happens in OMP and other things.
Exactly.
So,
OMP, you use it in SD-WAN, Lisp, you use it in. It's the same.
right, but they both act as a DNS server, right?
Exactly.
The
So
database.
you can relate it with the example of DNS. That's a good option.
Yeah, because Sunil, what happens is keeping millions of entries on each edge node, which is an access layer switch, doesn't make any sense in the
Exactly.
network, right?
And
Keeping
then the CPU goes down of this device. This is what is
That's right.
happening in the traditional network. That's the reason this thing is a kind of this work is given to a separate node, which is the control plane node, who dedicatedly does the only part.
So, Sopran, you said like, layer 2 is not needed. I'm more of a layer 1, layer 2 kind of guy, but if the switch still has a switch MAC address stable to forward, traffic, correct?
Glenn, let me interrupt you. I am going on to those points. Just
okay.
Hold on for some time. I'm sure all your queries will be answered. I know, like, it is you're more curious on knowing that. I understand your situation and everyone's situation, but just hold on, guys. You'll enjoy every bit of this. There is a lot more than this. You'll be answered with all these questions in a very detailed manner. Trust me.
Yeah. I mean, with these slides, it opened up a lot of Q&As. So because we have too many terms here, too many too many entities. So it's kind
I
of
understand. Yes,
yeah.
it happens. Yes, I know.
See,
no problem.
The shortcut that I see to explain this to the people who are taking SD-WAN classes, treat this guy as an OMP. If node A wants to talk to node B, the OMP will decide if they can talk or not, and those entries will be basically local to your switch table. So this switch table, it's not that he doesn't have a MAC table, right? He has a MAC table on a need basis. Whatever he approves, that entry, that ARP entry is now basically collected here. So he has a MAC table here, right? But he doesn't have a collective MAC table of all the switches of the world. If your company has 1,000 switches, right? All 1,000 switches have wireless and LAN and different devices connected. Every device in traditional network used to have a massive MAC table. You don't need to keep that massive MAC table. It is outsourced to Lisp. Now A wants to talk to B, they will consult him, and then they will have local ARP entries. Right? That's the closest one, basically. What do you say?
Because you probably revealed the entire secret of this.
Okay.
So Lisp is something that will run on that control plane node, right? That protocol is enabled.
Which runs between these nodes. Okay. So it will be on both the nodes. The sender
OMP.
as well as the receiver.
Yeah.
Same like OMP.
Okay. Yeah.
Sorry. So clear with this? Any questions?
I mean, we didn't let you talk about Fabric wireless controller. Sorry, but I think
no problem. There is again a different world of wireless as well. So the Fabric wireless controller. So if you look at this, you can see that this is not sitting anywhere inside this SDA, this Campus Fabric Cloud, because this is a limitation in SDA as of now. The Fabric wireless controller has to be deployed somewhere in the data center or in the DMZ zone, whatever the design architecture looks like, but it cannot be a part of the Campus Fabric. Yet there is a feature to enable a Fabric enabled controller. When you enable this, these access points, the small access points connected to these edge nodes, will communicate and authenticate with this specific wireless controller sitting outside the network, since it is fabric enabled. There, Cisco has given a wonderful, what you can say, an option where you can enable the wireless functionality even on the border node. There is a thing known as fabric in a box, which we call it like the border, the control plane, the edge, and the wireless controller, everything on one node. But that again, fabric in a box requires a very specific model to be used, and you have to consider the number of users. Now, if you are a small organization of 40, 50 users, that can be achieved. But if you are more than 100 users, that box, I mean, it can manage, but it wouldn't be that capable of managing such a request if every user is active at a given point of time. So this is the fabric wireless controller. These are the access points which actually communicate with this wireless controller. And I'll give you one more clue. This access point, when as a new wireless client, it first notifies this thing as a default action to notify to the control plane, and then a copy is sent to the wireless controller. So keep this in mind. Any endpoint connects, disconnects, the whole world knows who is connected where and who is disconnected where.
And one good question, Pranav. Traditionally in the Cisco Aris wireless world, the APs would create a cap-up tunnel to the controller if it's the 8540 or the VISMs. Do the APs in the SD-Access
Yes.
flavor
Yes.
also create a tunnel all the way to
Yes,
the...
they create the same CapWeb tunnel as well, but again, they first get connected here, then it is identified by the edge node with the help of control plane node that this is a access point. The same configuration has to be done here as well. Fabric wireless controller also identifies that yes, it is an access point, and then this thing registers with this via the edge node as well as the wireless controller. So CapWeb is, yes, it is still in use.
Okay.
So when you're talking about this fabric wireless controller here, Pranav, are you talking about Meraki solutioning, or is it like a totally different controller that Cisco is again put in?
It's again a different controller, the 9280. I don't exactly recall the model number. It is again a 9 series controller which works with this SD-Access architecture.
I think it's the 9800 series, right?
Yes, 9800. Sorry, you're right. 9800. It is
Is it-
CL 9800, I guess.
It's not Meraki again.
No.
No, because the fabric functionality has to be enabled.
Okay, so I mean, why is Cisco doing multiple? Because they are giving one solution via Meraki, and then again you're pulling out something again via SDA. Okay.
See, Meraki is for the SOHO and the mid-size business.
Okay.
These solutions are for enterprises, for
Exactly.
massive scaled organizations. So Meraki basically started as a SOHO, then Cisco acquired it, and they give it to the small companies and SOHOs and probably mid-size organization also. But this is an enterprise product.
Oh, okay. Because I see,
Yes.
because a lot of Cisco customers, I mean, I can talk about the big ones. I mean, they use Meraki as SD-WAN. They use it for even your wireless. So that's why I was wondering, why did they again bring a new solution here? I'm not
So
sure.
if you look at Meraki in detail, most of the solutions are not very scalable to 10,000 endpoints and 15,000 endpoints kind of thing, right? Especially when
Okay.
it comes to these policies and everything else.
Okay. Okay. Yeah. Possible.
Yes,
Okay.
these 9000 series is designed specifically keeping in mind the SD-Access architecture, because as you can see, there are a lot of new terms, terminologies, the protocols, everything is completely different. So to handle these kind of data, and these are so efficient that they can handle lot of more than 10,000, 20,000 requests at a single point of time. by communicating with each other. So that's the reason they have created a separate product line of the Catalyst 9K. Yes, you can use it traditionally as well. That's not a problem always, but specifically designed for the for making use of the SD-Access architecture. So this is the DNA Center where someone was asking about the design, provision, policy assurance. Yes, this thing takes care of the design, policy, provision, and assurance integrated with ICE for the policy part, network control platform for the automation on these devices, and network data platform for the analytics, or you can say the assurance. So to keep it simple, DNA is a hardware box. ICE is available both hardware as well as virtual. This integrates with DNA using PX grid for policy part. The control platform and the SD-Access feature, the SD-Access, what you can say, not or, and automation can be enabled either separately or together in the DNA Center, and the network data platform is the assurance. All these three pieces are combined together to form the SD-Access solution.
I'm sorry, Pran. I thought ICE talks using Cisco TrustSec, right, to DNA, or is it PX?
No. You're confused in that. ICE talks with these network devices using CTS, and it talks with the DNA Center using a protocol known as PX grid. TrustSec has nothing to do with DNA and ICE communication.
Okay, thank you for clarifying that.
Yeah, you're welcome. So the design part, if you see, deals with building a kind of hierarchy of all the campuses you have, defining what is your SNMP server, what is your AAA server. If it is integrated, you need not specify it explicitly, specifying the syslog server, and everything is gathered in this design section, but not yet pushed to any devices. Let's go step by step. In the provision part, this piece takes care of all the devices being managed from the DNA Center. The word I used is managed. So it is the configuration part. Everything is done from this specific option, provision, or the DNA Center's GUI. The port level configuration, whether to what you can say, allow a single identity or a group of subnet on that specific port, or make it a trunk port so that anyone connecting on that can have access to anything. Or we have a specific option that a wireless AP is connected on that port, so that the edge switch comes to know its access point and pushes the specific configuration related to the wireless access point, enables the CDP protocol on that port. Everything is done in this provision part. Policy part, this is all ICE. Everything is ICE in policy. The TrustSec part, the VN part, the policies, the SGT matrix, which is in ICE, the same you can create on DNA Center starting from version 1.3.3, so that you don't have to be logging into ICE separately. You can do it from DNA Center as well. It is reflected in ICE automatically. because of this specific protocol. I have a very nice diagram in the next 1 or 2 slides where you will come to know all these protocols and how it is done. And this assurance part is all about the network data platform, wherein you can monitor the network for any issues, the utilization, the health status of all these devices, kind of monitoring all these devices. The monitoring part is done by assurance piece, which sits here. So this is the entire solution of SD-Access, which has these many components. Now coming on to more detail, hardware appliance. DN1, now the latest one is DN2, DN2 hardware appliance, which is the nothing but a SNS server again, which has the DNA Center application installed onto it, same as it is done in ICE. ICE, everyone knows it's a SNS appliance, can be deployed virtually as well on the ESXi or Red Hat Linux. 3500/3600, which is the latest series. 3615, 3695, based on the type of deployment which you have, small, medium, large scale. And this thing, if you see, this was the diagram which I was talking about. If you see this automation or network control platform, which sits inside the DNA center, and this specific platform is used in the SD-WAN as well, ACI as well, and SD-Access as well. This thing internally communicates. This is not a separate device. That's why we have this into a single gray box. This is a single appliance but has multiple modules. This automation parts communicate with this DNA center, which you can relate it with the vManage, communicates via API. This assurance, which is the NDP part, NDP network data platform, communicates with again the vManage via API. This communicates with the actual configuration part or the automation part via API. This entire DNA center communicates with the campus fabric on these protocols, which we discussed: netconf, SNMP, SSH, and YANG as well. ICE communicates with these devices using AAA radius ePower LAN for the initial authentication, and we have CTS here as well. And these devices communicate with the assurance engine for like sending the raw data or sending the syslog data, HTTPS, NetFlow, syslog, or SNMP to this. If you have an external server, obviously these devices would send it individually to the external devices, but these send this specific data, NetFlow, syslog, and HTTPS to the assurance engine, so that assurance engine can identify the problems, or if anything is blocking, or if it has any health issues, the device has any health issues. So everything is monitored, and what you can say, the insights and the actual machine learning part is done in this assurance with this type of data and many more. And DNA Center integrates with ICE. It's API, but it's a Cisco protocol, PX. Great. Now we complete the fabric with all these. Yep. Questions.
Yeah, on the API towards automation, right? You put SD-WAN and ACI. Sorry, I lost that. I didn't understand. What was that for?
It is basically, this is your vManage, and this is the actual engine doing the work, which is the vSmart.
You are taking
This is not exactly SD-WAN. I'm just making it easy for you to understand.
Okay, yeah, that's what I thought. So you're trying to take a
Yes, yes, because I've got to know that most of you are enrolled for the SD-WAN course as well. So to make it more easy for you, I'm just using this example. I wasn't aware at the start, but like Vikas interrupted in the between that some of you are already enrolled in SD-WAN course. So to make it easy for you, for relating it, I'm using these words.
Got it. Makes it a lot easier actually. Thank you.
Exactly. Clear with this? Now comes the hardware specifications. DN1 hardware appliance. Already end of life, not recommended as of now. Focus on these two. DN2 hardware appliance, DN2 hardware appliance for large scale infrastructures. The specifications are quite high because the application of DNA Center is very heavy to run. Because by giving a restart, the application needs at least 15 to 20 minutes for the GUI to initialize. You can see the specifications. It has a 256 GB RAM, 16 GB, sorry, not GB, 16 TB SSD. I'm sorry for GB, 16 TB SSD. And the scale and performance, you can see it can handle 5,000 devices, 1,000 switches, routers, WLCs, plus 4,000 access points, and the concurrent clients it can manage is 25,000. And this is recommended for the small and medium SDA design. For medium and large scale, you can see 8,000 devices, which can consist of 2,000 switches, routers, or WLCs, and 6,000 APs and concurrent connections, and can manage 40,000 clients. Recommended for mostly large scale. This you can even go on to the Cisco's website, and you can just for the search for DNA Center specifications. You'll get the same information.
Pranav?
Yeah.
Yeah, hi, this is Saurabh. Quick question. So when you say 1,000 switches, is it Cisco proprietary or it's multi? They can support multi-vendor switches as well.
SDA is all Cisco.
Okay.
Yes. They are planning to make it a bit wide open for the other vendor devices to be, but till now, no news regarding that. So as of now, it's all Cisco. Clear? Now, speaking of the architecture of DNA Center, we have to make sure that it is a 3 appliance cluster when deploying it in real time. The reason for being is they have kept it odd number because 2 of them work simultaneously, and one, you can say it is ready for a swap. So if any of the 2 doesn't work efficiently or has any problems, the third one takes up. So you can see 2 nodes active sharing plus 1 redundant, and they connect to a single virtual IP. So you enter the virtual IP to access the DNA Center, and the services are not equally, not even unequally. They are distributed in a fashion which Cisco has developed, that like some 20-30 services are running on the node 1, 10 to 5 services are running on the node 2. Sometimes there are 2 or 3 services running on the node 3, which is the redundant node, and sometimes it is like 20 services running on the node 3 as well. So it is kind of internal communication between 3 DNA centers. One you can deploy just for a POC or a kind of small lab setup at your place or at your organization, but for deploying it for use for actual implementation into an enterprise organization, the recommended is 3. 3 appliances form a HD cluster of DNA Center, seen as one logical instance and connect to a virtual IP. And in there are very rare cases where some application gets stuck within the DNA center. Excuse me. So mostly Cisco TAC or one who has access, who has idea about the maglev CLI of Cisco DNA Center can get access of the SSH, but it is rarely needed. It's all about GUI. It's all GUI. So if you see, two nodes active sharing, one redundant. Some services are running on the running multiple copies. Like there are 20 services running on node 1. So might be 20 services running on the node 3 as well. You cannot, because the database replication is continuously going on, and we cannot like identify which service has been accessed on which specific DNA node, whether it is 1 or 3, because it is highly recommended to use virtual IP. And other services run a single copy and migrate from the failed to the redundant one. So if the second one fails, the third one takes over. Excuse me. Clear with this? Now this is a bit what exactly is done or captured. So if you see, this is the actual campus fabric. The data collection and the telemetry data. Telemetry data is nothing but the live data, how the communication is happening, the sys logs, the SNMP data. It is all captured by the NDP, or you can call it as an assurance engine. Align these options with the design policy provision and assurance options. It will be more easy for you to understand. That's the reason whether it is NDP, I'm specifying assurance, and whether it is assurance, I'm specifying NDP. So you have a good grip on that. So whenever you have any question in the interview, for example, what is the work of assurance engine? So you can confidently say that it does the network data platform work, collecting all the telemetry data and the raw data of SNMP and syslog for a better insight of the network, how it works, and to identify any possible errors in the network. Network data platform, like it provides a copy of the telemetry intent, the alerts and violations to the network control platform. This thing deals with the automation part. So if you see, there is a double arrow here, which means the network control platform does the configuration automation as well as the telemetry configuration required to push this data here. So for collecting the telemetry, obviously to collect the SNMP logs, you need to set up the like you have to define who is the SNMP server. You have to define different kind of traps which has to be enabled, sent to which server. So all this configuration is done via network control platform. You can call it as the automation thing, which is done in the provision stage. The inventory, topology, host group, network state changes, part trace information is given by the network control, that is the automation part, to the network data platform, so that this assurance engine is well known of what devices are there in the network, what is their state, whether they are active or they are in a failed state, and the part trace, that whether these devices are like reachable to each and every one of them. If they're not reachable, what is there a problem in the underlay? So all these things is known to this network data platform as well. Again, this network data platform helps for the troubleshooting part, to get an idea of how the network is running, what all data is running, are there any specific protocols running, like the telemetry data. It is more of a called of a telemetry data. There's a lot of thing in the NDP platform. They have like designed access point test devices as well, known as access point sensors, wherein you can test it with the assurance whether they give a proper data or not, how many, like the bandwidth used, everything is done in the network data platform. And with this comes to an end of this introductory or an overview session of Cisco SD Access. Any questions are open.